Chapter 1 of this course then focuses on Earth system science and society. So essentially raises many issues of how natural scientists have looked at Earth system as a very fascinating system for the various feedbacks between the atmosphere, cryosphere, hydrosphere, biosphere, and so on. And don't include the societal aspects or human agency very effectively. So this is a chapter which makes various interesting points about that. So looking at Earth system science, society, and anthroposphere, we will see what Earth system actually traditionally has meant in addition to what we already saw in the introduction. And as an adaptive system with human actions and choices, the needs for information and the context of climate impacts becomes very critical for taking decisions for the future in terms of policy and technological and other mitigative actions and adaptation efforts. The Malthusian model for the Earth's carrying capacity and limits to socioeconomic growth generally failed because they didn't take human agency into account. So maybe for those like us, climate scientists or natural scientists, agency is a word that is used a lot in social sciences. It basically means the ability and the autonomy to act in the context of an issue like climate change. So agency is the ability of individuals or communities to be able to act and having the autonomy to act. Sometimes they have the ability but not necessarily the autonomy. So those are the things we have to worry about. Plus we will look at what anthroposphere actually means in this context. So this daunting figure actually comes from the Brotherton report from the 1980s, which emerged out of Europe, but this is from a NASA report from 1988. Obviously, all relevant physical, climate, and biogeochemical things are in here. On the left, we have the external forcing like solar and space plasmas and volcanoes. These are basically, when we say external forcing, these are things that affect the radiative balance at the top of the atmosphere. Okay, so energy balance of the system, which determines the change in climate, like warming and then everything that follows. But human beings are also put out here on the right side as an external forcing with their emissions, and they also receive the impact of the changes they induce. But you can see that the internal piping is mostly related to physical climate system and biogeochemical cycles and the feedbacks between them, with various time scales going to deep sea sediment cores, which are hundreds of thousands of years, mapping and solar system orbital forcing, which are thousands of years as well, ellipticity, obliquity, and precession. And you have signatures being stored on those long time scales also in deep sediment cores, ice cores, and lake cores, and various other speleothems, etc. Okay, so the idea is to worry about the persistent and broad scale social structures and processes that underlie the changes we worry about, including the impacts. The impacts are not purely dependent on climate change variables like temperature, extremes, droughts, floods, but also depend on the societal structure that is bearing the brunt of those impacts. The outcomes actually depend a lot on the vulnerability of the communities exposed to those hazards. We will see more of that. In particular, what are the relative roles of the amount and concentration of human population, the character and use of technology, right? For example, in agriculture, changing relation between places and of production and consumption, so things being manufactured in China and being used in Europe, US, and the rest of the world, and the reach and power of state and other institutional structures like, let's say, UNFCCC, which is coordinating the global negotiations, and so on. How does the relative importance of these roles of environmental change vary across cultures and through history? That has to be understood as well. Quickly, we will look at what Malthus actually missed in terms of the population bomb. So there was a super exponential increase in population from less than a billion to 7 billion by now. And expected to continue by some projections. But the Haber-Bosch process, or the industrial production of ammonium and fertilizers and bombs, of course, made green revolution possible, and basically the Malthusian crisis or disaster didn't happen in terms of famine, starvation, and mass deaths. Right, so that was missed. Food production versus supply. So this idea of efficient yields and supply routes, global food trading, etc., were not envisioned by Malthus. Nonetheless, if you just look at the human ecological footprint in terms of the number of Earths we would need, here is Earth at 1. Its carrying capacity is, of course, limited, but the human consumption patterns in terms of exploiting the carrying capacity has far exceeded 1 Earth now, and we are heading towards somewhere here into 1.25 Earth or so in terms of use of natural resources, food consumption, primary production being consumed, fish being consumed, etc. Okay, so we will come to this IPAT model in the next podcast, but I hope you get a sense that Malthus imagined, and even Paul Ehrlich in the 60s or 70s talked about population bomb, but it hasn't quite materialized in terms of mass starvation. But there are pockets of starvation, undernutrition, etc., which is also related to supply issues and food waste. There is a massive amount of food waste. So any climate, Earth system science analysis, predictions, projections have to account for all those human impacts on the problems we create and try to solve, and the unintended consequences that happen when we are focused on one thing instead of the system view of the problem. That's the main point of this course.